Okay. Good morning, student.
Hi, sir. Hello. Good
Good
morning.
morning, sir.
Good morning, sir.
Okay. So we will continue our study before. Yesterday we have talking about the IoT application architecture, and we continuing our topic. Okay. The next 5 layers architecture. In the 5 layer IoT architecture, we have 5 stages here. You can see in the lowest layer is perception layer or object perception, and on the second we call it abstraction and service management application layer, and in the highest layer is business layer. But it is similar for all layer that we will talking about for today. For 3 layer, for layer 5 and 7 layer, it has a similarities. Okay, so okay, okay. It is a explanation for every layer. In object or perception layer is the lowest layer. It's same with before. So in this layer, you can find sensor, controller, and actuator. Okay, this is the type of the sensor. The type of the sensor is a various sensor like ultrasonic sensor for distance sensor, peer sensor, and humidity and temperature sensor, raindrop sensor, many sensor here. So you need to learn and you need to make a practical to how to use these sensors and how to communicate with controller, and also how to program controller and make actuator can run by our program. So in this on this layer perception layers, we can find sensors, many type of sensors like temperature, humidity, motion, chemical change, and everything about physical sensors. We will talking about sensors in the special day in the next week. In Monday and Tuesday, there is another lecture. Another teacher will be teach you about sensors. Okay, it's clear, right? So it is the same with before. So it's a device layer or perception layer or object perception layer. So there is a same similarities on this layer. Object abstraction layer. We call it before communication layer. We call it before communication layer. So it is the same. You will find many type of communication technology and many communication protocol like Wi-Fi, infrared, Zigbee protocol or Zigbee device, Bluetooth Low Energy, GSM, 4G, 5G, and other type of communication technology. The network layer transfer the information from the perception layer to the service management layer. And the next is service management layer. Okay, service management layer, we call it before middleware layer. But in this type of 5-layer architecture, we call it service management layer. It's just the different name, but same function. It's the same function. In the middleware, we make a software. We make a application or software that function for interface between IoT device, IoT components to our server. Okay, so it has a function for bridging. Bridging means to catch up the data, to receive data from the IoT device, and then it will be transferred to our database or our application for visualization. So in this layer, we will learn about API, application programming interface. As far we know that API is very important uh, application for many type application like mobile page program, like mobile application and web application, right? I think you have learned before. I think you have learned before in your class with your teacher about API. So it's same with concept. Same the concept is same with application, mobile application. Uh, the difference is just if you use mobile application, the end device is mobile device like smartphone. But in IoT, the end device is microcontroller. So they use the same concept. In mobile application, the end user, the end device is smartphone. But in IoT, the end device is microcontroller and IoT device. So don't worry about the communication concept. So this is the same with application flow. So okay, we will talking deeply about this API in the next day. So its middleware is very important because it has a function for receive the data and then forward to our server and our application like visualization data. How about application layer? Application layer, it means database, how we can save our data and how we can display our data in visualization application. It's located in application layer. So in this layer, we will develop the software that we can to display our data from IoT device and make some controlling and monitoring data from the application. Maybe you can make some web application, web-based application, or maybe also you can make a mobile-based application like Android or iOS, application. So in this layer, we will talking about data warehousing, big data storage, data mining, and another semantic data analysis, to make a performing semantic data analysis. And in the last layer, in the concept 5 EOT layer, namely business layer. They call it business layer. It means the business layer is responsible for managing the overall activities or services of the IoT system to create the creation of flowchart, business model, and graph on the process data received from the application layer. You can imagine that if you have one company, so you can imagine, for example, if you have one company and you want to monitor everything in your factory. So you have a factory, for example, a small factory. In your factory already running IoT device that monitor overall and everything that in your factory, like motor, like sensor, and another type of the sensors. All data will be transmitted to your server, and you can monitor everything about your factory performance. What will you get from this data? If you have as many data, real-time data that coming to your server, and you can look the data in real time. So what can you do with your data? Maybe you can make some data analytics, like you can make a prediction. You can make a prediction how many things that you can produce, you can make, or you can make production in 1 month. Or maybe you can make some prediction how many things that we can make in the next month, based on data that IoT already sending in your server. You can make some prediction. You can make some prediction and make decision. You make some decision planning. You can make a planning for your business, for your factory management. You can make planning for your inventory and another type of decision making, based on data. So in this layer, they want to show to you that from IoT device, we can make many decisions in the management. So in this layer, management has a role person. This is the very important person in this layer, because management can make like prediction, and like they can make decision based on the data. So that's why in this layer they call it business layer. So it means in the future they can make some decision for the future based on the data from IoT device. It's very interesting. So in this layer, you need to learn about a big data analysis, business intelligence, for supporting automated decision making. It is very important. Automated decision making. If we can make a program, if we can make a software, if we can make an algorithm from based on the data that enter our server, we can make some automated decision making. So it is very helping for our management to make some decision, important decision to our business. Maybe it is about prediction, and maybe about the another type of decision that make a company will be a better before. And the last is 7-layer IoT architecture. So in this layer, it has also similarities. We have a physical device layer, connectivity layer, edge computing layer, data accumulator layer, data abstraction layer, application layer, and collaborating layer. So they combine 4-layer architecture and 5-layer architecture, and they make a 7-layer architecture. The explanation is same for the things layer. We still talking about the sensor, actuator, and controller. It is a device layer. In the connectivity layer, connectivity layer, sorry, connectivity and edge computing. Okay. Connectivity means, yeah, everything that you need to communicate your device to a server, we can put in this layer. So many type of communication technology that we can choose based on our case. We have talking before that many type of communication technology like LoRa, like BLE and other. In other words, the function of this layer is to perform horizontal communication between smart things layer to switch to routing and secure data transmission at different network layer. Okay, I think we can next do the next layer. Now, this is a very important the layer in 7-layer architecture. We call it edge or fog computing. You can imagine on this picture, if you have many things like sensor, control, and actuator, maybe you have a robot, we have a drone, and we have many type of IoT device. You can communicate to, and you can transfer the data to gateway before you transmit the data to IoT cloud application servers. I have some case for this layer. Maybe you know about self-driving car, you know. Self-driving car, this is very possible to implement 7-layer architecture. They need a 7-layer architecture. Why? Because it is a very complex application. Okay, self-driving car. If you know the self-driving car, like Tesla product or another product, they need some application, some artificial intelligence application, because it use a camera. Normally, it use a camera to detect, to capture everything in this way about the surrounding environment, like car or everything. They need to make a detection. It need to make a detection about the surrounding environment. So we need artificial intelligence application here. So we need the object detection, object detection. Use a TensorFlow, for example. Okay, this is the implementation of object detection using deep learning. Deep learning is one of the type artificial intelligence method. You can learn in the another course maybe. The simple word that the camera will be a smart because this camera connect to central processing unit, connect to computer that running deep learning software or deep learning algorithm. Okay, this we need some application like TensorFlow. We need some application like TensorFlow or Keras or Theano. There are many software that we can use to make a artificial intelligence or deep learning application. For example, we use this TensorFlow application. TensorFlow application will make some detection about everything that camera can capture real time, not only static image, but also the video streaming. So it can process real time. It can process real time. If the car is running, the camera also they capture the picture every in the real time condition, and the algorithm the deep learning algorithm or the deep learning software, they will process it in the real time also. So the problem is how we can put the computer, how we can put the computer in the car, right? Because for running this software, for running this deep learning application, we need the huge computation. We need the high computation. We need the high computer processing. This is the problem. If we use just a low specification computer, it cannot to run smoothly, right? So we need a solution for this case. The problem is if we put the big computer in our car, how about the electricity? Is the problem. How about the electricity? We don't have the big storage electrical energy in our car. We just have a battery. We just have a battery. But how it is possible for battery to energize our computer? No, it is impossible because the computer it need high voltage energy. For example, maybe you will thinking about the computer for gaming. I think computer gaming like CPU. Uh, uh, is a computer gaming. It can to use for process our deep learning application. Yeah, we can use this type of the computer to process our deep learning or artificial intelligence application. But as far you know that this CPU, this computer, it need a high energy, right? Maybe it is about 800 watt or 700 watt, 700 until 800 watt energy, and we need to connect this computer to the electricity, right? It is to make our problem if we want to implement this computer to our car or our self-driving car. Uh, so what is the solution for this case? I will introduce to you one of the technology. I think it's a new technology. I think it's the single board computer. It's the small computer, but it has a small size, but it has high computation ability, and it's ready for processing for deep learning application and AI application. We call it a single board computer or mini computer or mini PC. There are many brands that offer this type of the technology, like NVIDIA SEAMEO. This is for NVIDIA. You know NVIDIA. I think all of you know about NVIDIA. It is the graphic card company. They make some type of the small computing device. One of the cheapest of their product is the NVIDIA SEAMEO. The price is about maybe $200, 200 US dollars. I have one in our home. Okay, this ready. It's ready for deep learning application. It's ready for AI, artificial intelligence application. And the good news is it needs a few energy. It's minimum voltage energy. They just need about 5 volt DC. Just 5 volt and 2 ampere. Maybe it's about 10 until 20 watt. You can compare. If you use the computer gaming, you need 500 until 800 watt. But for if you use this type of computer, you just need maybe just 20 watt energy, electrical energy. It is very possible if we can implement this technology, these things to our self-driving car. Now, we call it the edge computing. We call it this is fog computing. So we put the computer with a high computation but low energy in our IoT device. It's explanation. It's explanation about the fog computing or edge computing. So we move a computation to edge. Edge mean IoT device. Uh, actually, we can process in the cloud in the server because we know that many server it has high computation, right? Many server had high computation. Normally, it has 8 gigabyte RAM or maybe Core i7 and so on. But the position, the cloud server, it is in the central room, not in the edge. It is the problem. So we need to transmit data, many data to IoT cloud server. So it's not efficient. It is very not efficient because we need the high bandwidth. We need to high bandwidth and high data. We need big data to transmit to our server. It is impossible because the connection in our condition maybe just we need to make a little data, a small data. So the solution is we can process the computation on the edge, on the edge in here, not in here, but in the IoT device. But it has the problem because we just have a small energy, so we need to choose the small energy also for computation. And single board computer like NVIDIA Jetson, it is the solution for our problem. How about the any brand except NVIDIA Jetson? Many brand like Intel NUC, maybe Intel NUC, Intel NUC. Okay, it's also the small PC, mini PC. It can run for computation, for deep learning, for artificial intelligence also. But as far I know, this computer, this product, it needs higher energy than NVIDIA Jetson. Maybe it is a 10-fold and 5 ampere. So maybe it's about 50 watt for energize. But NVIDIA Jetson, I know it's just 20 or 10 until 20 watt. So you can consider which one the best choice for your case. Or also there is another brand like Latte Panda. Latte Panda, it is also high computation for small PC. Discrete also, it's discrete, but it don't have graphic card. They don't have graphic card. So maybe if we compare with NVIDIA Jetson Nano, the champion, the winning is Jetson Nano, because Jetson Nano it's already include graphic card on this computer, on that board. I hope you can understand for this explanation. So for the fog computing, for the 7-layer architecture, you can implement this architecture in the case like self-driving car or another type or another case that use artificial intelligence or AI in this application. And the highest, oh no, this is the cloud layer. The cloud layer is the same with application layer. So you put the database, visualization application, and another software that you install in your server. And the last, they call it the data abstraction layer. Data abstraction layer. Oh, sorry, it's not the last. The last is collaboration. The last is collaboration layer. The data abstraction layer, it means like middleware layer. Middleware layer is API application. It's for bridging and to accept to catch up the data from the IoT device. And the last is collaboration and process. We make some application for business. This is like 5-layer architecture. We combine with the business field to make some prediction, to make some decision making based on the data. This is a 7-layer architecture. So we want to highlight for this material, for this topic. In IoT, different people with different purpose can use the same application. Okay. And in IoT also, the decision for the choose which one the architecture layer, it is based on our case. If you use self-driving car technology, you need to make a 7-layer architecture. But if you just want to make a simple application, for example, you want to monitor the traffic or you want to monitor the recycle bin, maybe you just need 3 layers or 4 layers architecture. So it's very depends on your case. For example, in industry like factory and another type of factory, it is a big implementation. It's a very big, the big case, because many type of sensors, many type of actuator. In industry, we have all of this type of these things. Maybe you in industry also they use deep camera and another type of communication technology like Zigbee, like BLE or Bluetooth Low Energy. They use everything. They use many type of technology. And then every IoT device will be sending the information and data to server. We can use server or cloud server like ThinkSpot server. ThinkSpot is cloud platform. It's free for 30 days only, but this is very useful if you want to make some IoT application rapidly, and you can choose the ThinkSpot application. You just make a drag and drop setting. You don't need to make some computer programming ability. You don't need for learning or make a server, but you just to register and make some setting. You can tuning some setting, and you can connect your device to your platform in Thingsford. Okay, and also you can choose any application protocol like MQTT application protocol or HTTP application protocol. And also you can choose any type of database, you know, NoSQL database. Uh, NoSQL database is also it's new and very suitable for IoT application because it's a lightweight or agile or its speed. The speed is very high. Then database like MySQL or another type of SQL database. NoSQL has a high performance than MySQL or another DBMS database. So it's very suitable for our IoT application. There are many brands for NoSQL database like Cassandra, MongoDB, Redis, and another type of NoSQL database. You can use this type of the database for saving your data, IoT data. And another software that you can use also is Apache Spark. Apache Spark is software that is a very high size software. So this software for manage data, for data analytics. You can make some prediction using some theory, some algorithm like classification, like deep learning also using this software, using this Apache Spark software. So this software for data management, for data analytics. So it is the overall of our IoT technology. You must ensure for the lowest layer, it is the IoT device layer, and how to communicate the data to server, and how to process the data using many type of technology like Apache Spark and another type of artificial intelligence for big data analytics. Many case that we have some IoT case in our for example, IoT implementation in industry case. You know, we can implement IoT in heavy industry. For example, for controlling the robot, for make augmented reality and virtual reality glasses, and to monitor the logistic, monitor the inventory, monitor the real-time condition of our machine, because as far we know, in industry, we cannot shut down the machine for 1 day or 1 hour, or maybe we cannot shut down the machine for below 1 hour, because it will be make a high cost, high cost. We cannot make a shutdown. So we need to maintain. Every machine in our industry. The problem is how to monitor every machine in our industry, because many machine in our industry. Maybe it's 100 or 1,000 machine. Machines mean sensor, actuator, motor, and another type of the machine in our industry. They need to monitor. They need to monitor because we don't want to in the same time there is a problem with our machines. So uh, we try to monitor and we try to make maintenance frequently. So we can use IoT for monitoring every condition in our machine. So we can ensure that our machine will be okay and will be in the good condition every time. And uh, we can make some mitigation if there is some machine that make a trouble. We can make mitigation before. So our industry, our machine will be still run smoothly without any shutdown operation. And also in the use case, IoT use case, we can implement IoT in our tracking truck, in the truck or in the asset management, and every asset management like in the vessel or in the truck. For example, if you want to tracking your truck or your logistic truck, where our truck today in this time, we can show it the map, we can show it the map and we can monitor every movement of our truck. We can implement this type of IoT device in every truck that we have. So we just install GPS and controller to communicate with our server. It will sending the position every time, maybe every 15 minutes or every 30 minutes, they will sending the update or they can update the position of the truck. So we can monitor all of our assets. This is very useful for logistic company. And also we can use IoT for smart irrigation system in agriculture. For example, we can use for irrigation. Irrigation, irrigation. Irrigation is for agriculture. So we bring water from the source of the water and we put in every farm field that we have. We can automate this process using IoT device. And in the smart city, there are many applications that we can use in smart city, like how to make a detection traffic jam. Detection of traffic jam. Maybe you can use a camera and you can use computing or edge computing. So we can implement 7-layer architecture for this application because we need to process the traffic jam using camera. Camera will be processed using artificial intelligence and transfer the data to cloud server. Or maybe another case like smart parking monitoring, or maybe you want to sensing the amount of CO and O2 or oxygen or carbon dioxide and another type of gas in your city. Okay, energy management also you can implement IoT. For example, there is some new concept about grid power. About the grid power. Grid power means every home, every house in our for example, in your country, every house they will make self-energize, like using solar cells, and they can produce energy, and they can produce electricity in every house, and they can selling their energy to company, to electricity of company. So we need to make some monitoring condition and how to ensure that our electricity can sharing connection with the network, electricity network in our country. It is very complex, but it's possible if we want to implement IoT on this energy management. And smart parking, water system, okay. And smart parking also, we can implement IoT here. It is very simple, we just need one type of the sensor, like ultrasonic sensor. We can fit here and sensing the distance. If there is some car below the sensor, the distance will be decreased, and you can sending this logic to our controller and to server, so we can make some monitoring slot, monitoring the free area for parking. I think it is very simple, but very useful. Yeah, very useful for our place. Okay, I think this is enough for today. Okay, if you have a question, okay.
None, sir.
Thank you, sir.
Okay.
Thank you,
There's no
sir.
question.
None
There's
so
no
far,
question.
sir.
Sir. Thank you, sir.
Okay. If you have a question, also you can chat in the WhatsApp group, or you can type in the group. Okay, thank you all today. See you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.